Alright, we are moving on to number 5, and it says given f of x, graph g of x. Now they're assuming that what you're going to do is find the x and y intercepts of the first function, then you're going to look at the second function and determine what transformations are affecting the first function. So we're going to do it that way. Now, you should recognize that you can simply use your graphing calculator, graph the second function, and sketch it. But I am going to walk you through doing it the way they're thinking you're supposed to do it. Alright? They're thinking that you're going to find the x and y intercepts, and let's do that first. So looking at number 5, f of x equals 2x minus 4. You should know how to find the intercepts by now. F of x is the same thing as y, so you have y equals 2x minus 4. To find the y-intercept, you put a 0 in place of the x. Seems backward, isn't. When you put a 0 in place of the x, your y-intercept is negative 4, because 2 times 0 is 0. To find your x-intercept, you put a 0 in place of the y, which would give you 0 equals 2x minus 4. You would add 4 to both sides, which gives you 4 equals 2x. Then you would divide both sides by 2, which cancels the 2 on the right and gives you x equals 2. So your y-intercept is negative 4, and your x-intercept is 2. Then you would look at the second function, g of x, and you would determine what type of transformations are affecting the first function. Because it says negative 1/2 times the first function minus 1. So if you take the first function and you subtract 1, what type of transformation is that? If you take the first function and you multiply it by negative 1/2, what type of transformation is that? Now I believe that that's right around 9.3, and you're going to need to look back. Yes, it is. And you need the chart on page 672 in order to figure out what transformations are impacting the function. So you look there and you see which transformation has the negative 1 on the outside of the function. Horizontal translation would have the negative 1 inside the parentheses with the x. Vertical translation has the negative 1 outside the parentheses after the f of x. So that makes it a vertical translation, and since it's less than 0, being negative 1, it's going to be down 1. So just jot on your paper that that one of the transformations is down 1. Then the function is being multiplied by negative 1/2, and the negative 1/2 is on the outside. It's not on the inside of the parentheses, it's on the outside of the parentheses. So look back at page 672 and find the one that has negative 1/2 on the outside of the parentheses, and that is vertical stretch or compression for the 1/2. We'll deal with the negative in a second. 1/2 on the outside or before the function is between 0 and 1, so it is vertical compression. I hope. Yes. Okay? So you're moving down 1, and you have vertical compression of 1/2, and the negative is on the outside of the parentheses, not on the inside. If it's on the outside of the parentheses, it's a reflection across the x-axis. So you'd write reflect x-axis. So you have 3 transformations that are happening to your function. Down 1, vertical compression of 1/2, and reflect across the x-axis. Now how does that impact your x and y intercepts? You need the table on page 673, and you look up those 3 transformations that we just listed. So the first thing you look at is down 1. How does that impact your x and y intercepts? Well, a vertical change is going to impact the y value only, because that means that the function is moving up and down. Anything that moves up and down is going to change the y value for sure. Vertical translations, let's see if it tells us. Somewhere in here I saw an example of that. Yes. If you look on page 674 at example 3, at the very bottom, the last paragraph in the solution area, it says the second transformation is a vertical translation 4 units up. Use a table to shift each identified point up 4 units. So since ours is going down 1, then your y value will go down 1, which means your new y-intercept is -5. Then you have a vertical compression of 1/2. So look back at page 673, find vertical compression, and it says the x-intercept stays the same, and the y-intercept is multiplied by 1/2. So find the y-intercept, -4, and multiply it by 1/2, and you get y equals -2, except then we move it down. So you got y equals -2, it goes down 1, so y equals -3. Remember, we moved it down. So you take the y equals -4, divide it by 1/2, which gives you -2, and then shift it down 1, which gives you -3. Now you have to reflect across the x-axis, and in your book it says when you reflect across the x stays the same, and the y-intercept is negated. So since our y is -3, that means our y is +3. So now you have your new intercepts, x equals 2 and y equals 3. You plot those 2 points on your graph and connect them with a line, and you're done, because this line was linear. Here again, I think it's probably easiest to type it into your calculator, the new equation, and graph that. You would type it in with the f of x in place of the x. Trust me, it's easier. Alright? Good luck with that.